Good afternoon. Today we're going to go through velocity and acceleration and how that relates back to our vector valued functions. So I'm going to go ahead and have you write this down. Okay, we have a particle that's moving in an xy plane, time greater than or equal to 0. That makes sense. And the position, notice how I say position, is given by x of t equals t cubed plus 4t squared, and y of t equals t to the fourth minus t cubed. So the first thing I'm asking us to find is the velocity vector. Okay, well, here we have the position. Okay, so our velocity vector is just going to be the derivative. So our velocity vector will be 3t squared plus 8t. That is our horizontal component. Our vertical component would be 4t cubed minus 3t squared. Derivative of x of t, derivative of y of t. Then if I want the velocity vector at 1, we can plug 1 into that. So plugging 1 into the horizontal component, we get 11. Plugging 1 into the vertical component, we get 1. Okay, seems pretty straightforward enough. Let's talk about the speed of our particle. Now, remember, when we talked about speed before Thanksgiving, we talked about how it was the square root of dx dt squared plus dy dt squared, okay? Well, now that we're working with vector valued functions, that's not going to change, okay? So dx dt squared would be 3t squared plus 8t, that quantity squared. Dy dt is 4t cubed minus 3t squared. So if we want our speed at 1, then we can plug 1 into this expression. So we have 11 squared plus 1 squared. So our speed is the square root of 122. Okay. Now I'm asking you to find the acceleration vector. Okay. Well, if we come back up here to our velocity vector, we know that the acceleration is just the derivative of velocity, okay? We're just in vector form, that's the only difference. So, if we look at our velocity vector, then our acceleration vector is going to be, well, the derivative of the horizontal component would be 6t plus 8. The derivative of the vertical component would be 12t squared minus 6t. So then if I'm asking for the acceleration vector at 1, we would have 14, 6. Okay. Now, this is a pretty straightforward example, and we're going to get a little bit more complicated, but what we're working towards is more of our AP style of free response questions, okay? When we get to the AP test, one of your questions of the 6 free response will be either parametric or polar. If it's a parametric free response question, it's going to be in that vector valued function form, and they could ask you things about velocity, speed, acceleration, things like that. So we're going to kind of look at basically some different AP style of questions throughout the rest of our time. Okay, so here is another one. An object is moving along a curve in the xy plane with x of t comma y of t as the position, we know that dx dt is t sine of t. That kind of got typed funky, sorry about that. We know that dy of t is cosine of t squared. Okay. At time t equals 2, the object is at position 1, 4. Okay, I do need you to get out your calculators for what we are going to do. Okay, so make sure you have your calculators out, and since I'm really not sure what's happened since we took that quiz, make sure that your calculators are in radian mode. Okay, please make sure they are in radian mode. Okay, so the first thing I want to do is figure out what our acceleration vector is for the particle at time t equals 2. Okay, well, our position, they didn't really give to us. They gave us dx dt and dy dt. Well, they basically gave us our velocity vector, okay? Our velocity vector would be t sine of t and cosine of t squared, okay? So our acceleration vector, which is just going to be the derivative of the velocity vector, would be product rule 1 times sine of t plus t times cosine of t, okay? And then over here we would have negative sine of t squared times chain rule 2t. Okay, so now with your calculator, we are going to need to plug in 2 for our time so that we could get our velocity, or excuse me, our acceleration vector. So plug 2 in for both components. Make sure you are rounding to 3 decimals. Okay. So we get 0.077 and 3.027. Okay, now I want us to write the equation of the tangent line to the curve. Now, let's remember that a tangent line equation we write like this. Okay, well, we know that t equals 2. Okay, so let's come back up here. When t equals 2, we know that our position is 1, 4. So we at least know that we can plug in here y minus 4 and x minus 1. Okay. Now, for our slope dy dx, we know is dy dt over dx dt. Okay, and we need to evaluate it at t equals 2. So we need to take dy dt cosine of t squared over dx dt t sine of t, and we need to plug in t equals 2 to that expression. You should end up with a slope of negative 0.359. Make sure you can get that in your calculator. And here is your tangent line equation. Okay, now let's find the speed of the vector. Okay, so we know that speed is the square root of dx dt squared. So t sine of t squared plus dy dt squared. So cosine of t squared squared. So if we want the speed at 2, we're going to have 2 sine of 2 squared plus the cosine of 4 squared. So once again, with your calculator, help me out. You should get 1.932. Okay, next, let's find the displacement of the particle from 2 to 7. Okay, so let's think back to what we would have done last spring when we were in our motion unit. If I asked you for displacement, then you would simply take the integral, the definite integral from a to b. Okay, so that's what we're going to do here, except we're just going to need to do it twice. So we're going to need to do it once for our horizontal component with dx dt, and then a second time with our vertical component and dy dt. Okay, so this will give us the displacement in the horizontal direction. This will give us the displacement in the vertical direction. Okay, so how about you go ahead and find those two numbers for me? You should get negative 6.362 for your vertical displacement, horizontal displacement. And then you should get 0.097 for your vertical displacement. Okay, now we want to know the distance traveled by the particle. Okay, well, if we think back to, once again, that quiz right before Thanksgiving, distance traveled is the integral from a to b of the square root of, well, pretty much what our square root is for speed, dx dt squared plus dy dt squared. Okay, so go ahead and put that into your calculator. you should get 13.229. Okay, so this is the distance traveled, however that particle went, okay? If we straightened out that squiggle, this would be the distance that that particle traveled, okay? Now, last but not least, I want us to find the position of the particle at time t equals 1. Okay, now we know that the antiderivative of velocity is going to get us position. Now, if you try to take the antiderivative of t sine of t, that's going to be fine because you're going to be able to do that with integration by parts. But if you try to take the antiderivative with the cosine of t squared, that's not going to work. Okay, that's not something that we have a method for. So what we're going to need to do is we're going to need to use our calculators, but our calculators can only be helpful with a definite integral. So let's just remember the fundamental theorem of calculus that says the integral from a to b would be the antiderivative at b minus the antiderivative at a. So if we take the integral from 1 to 2 of our velocity vector, okay, then that's going to equal the position vector at 2 minus the position vector at 1. Okay, so what we're going to have is we're going to have the integral from 1 to 2 of t sine of t, comma cosine of t squared dt. We know that the position at 2 is 1, 4. And we're finding the position at 1. Okay. So in your calculators, go ahead and take this integral right here, the integral from 1 to 2 of t sine of t. You should get 1.440. Now go ahead and take the antiderivative from 1 to 2 of cosine of t squared. You should get negative 0.443. Okay, so if we actually solve this little equation here for our position at 1, our position is going to be negative 0.440 for 0.443. So what I need you to do for the rest of the time is to work on the worksheet that you are about to receive. Whatever you don't get done in class will be homework due tomorrow. And tomorrow we're going to look at some very specific AP free response examples in class. Okay?